Hello everyone. Thank you for joining DataCon LA 2022. Welcome to Data Engineering Track. My name is Hari Krishnan, your host. Our co-host today are Courtney and Viva. Please be mindful of our COVID regulations and keep your mask on if you like. Also silence your phone during the session. The session is currently streaming via Zoom and will be recorded. It will be available online in a few weeks. Today we have a guest, Ravi Pillala, and he will be talking about modernizing analytics and AI for today's week, Intuit TurboTax Case Study. One key takeaway from today's session would be learn, inspire, and understand different fit for purpose solutions. Ravi is an experienced architect with a valuable blend of technology and business skills and a passion for innovation and building and enabling high-performance teams. He is research-oriented technology leader that loves to architect and deliver cloud scale, highly secure, resilient, and overall world-class technology solutions. He is a software and systems architect that emphasizes the alignment of technology solutions with customer developer needs to accelerate business outcomes. One fun fact about Ravi that he wanted to share is that he skipped his sixth grade from fifth grade and he joined directly with study. There will be 10 minutes towards the end of the presentation for Q&A, so please reserve your questions for them. Without further ado, I'll hand it over to the speaker. Thanks for being here, Ravi.
Thank you, Hari. Thank you, everyone, for coming here. I'm excited and delighted to share our Intuit's journey in modernizing the analytics and AI platforms. I'm just taking the TurboTax use case today. Before I jumping into the details, I just wanted to ask how many of you know about Intuit? Oh, I didn't expect it. Thank you. A lot of you know about it, but Intuit journey started 4 decades ago at a small kitchen table by our co-founder, Scott Cook, when he observed his wife struggling to balance the family checkbook. He thought to himself that there has to be a better way. And that moment, the idea for a product called Quicken came to life. Many of you know about the Quicken product. And a mission to a company born. We are a value-driven, purpose-driven company, and our mission powering prosperity around the world. That's a single reason why we show up to the work every single day. Our values drive what we do every single day. We provide a software and services for the consumer, small businesses, and self-employed through our flagship products, TurboTax, QuickBooks, Mint, MailChimp, and Credit Karma. Credit Karma and MailChimp is acquired in the last 2 years. Look into our customer volume overall. I don't want to go through all the numbers here, but I want to focus here only at the TurboTax case. We have 56 million unique tax filers last year. 56 million. Think about it. Every tax filer's financial story is different. It's not unique. And we need to cater for all those 56 million through our product. We need to provide those 56 individual stories to be mingled together and provide our services and help our customers. So before I jump into the technical details, who are our customers and see what their stories looks like. I'm not going through 56 million here. I picked a sample of 3 based depending on a different patterns here. Liam, he's basically divorced 2 years ago. Last year, he claimed his daughter as a dependent. This year, his wife is going to claim his daughter. He changed the jobs from Toyota to Honda, and he was renting a condo. Now he was renting earlier. Now he bought a new condo. So his goal is basically wants to file the taxes confidently for the change in his life situations, changes in his life. Same as Stacy. Stacy is basically a returning TurboTax customer, but she lives paycheck to paycheck. But she wants to know what is her tax returns looks like. Many of our customers, the biggest paycheck of the year is their tax returns. And she has a big plans to how to spend that tax returns money. hope many of you are waiting for the tax returns when you file that money to how to spend it. She wants to make sure that get an early view on how the tax returns looks like so that she can plan. And she wants to pay as little as possible to file her taxes. Lisa, she is a veteran customer. She's new to TurboTax. She came to the country and she had a baby and she bought a house all in 1 year. She doesn't trust herself in filing the taxes. She wants someone to handhold and navigate through the filing the taxes. All she needs is confidence in filing the taxes. That said, this is not a tax filing is not a fun experience. It's not like everyone enjoys filing the taxes. It's one of our obligations to file the taxes. Sometimes it is frustrating too. Every customer wants to help their personal needs. Like we don't want it to throw a stereotype of messages. We wanted to personalize their needs. They can reach us in multiple ways. They can talk to us through calling our customer care service, and they can initiate a chat. They can schedule a call. When I'm free, call me back. They can go through the self-help articles and typing in their personalized situation and get the help what they need it for. Like Lisa kind of situations, they might need a TurboTax Live expert, tax filing expert, help her navigate through filing the taxes. But this is the ideal dream we had a couple of years back. But how do we make sure that we can help them to serve for their personal needs and customize the help? When the customer calls us, make sure that we navigate the calls based on their situation, who the expert is, expertise in that area, and navigate the calls towards that direction. At the same time, if they are initiate the chat, we want to navigate those kind of situation, understand their situation, and navigate those chat to our respective agents. There is something needs to be happening behind the scenes. A couple of years back, we realized we need to upgrade our systems, modernize our systems from the backend standpoint in 3 different areas to help our customers much better way. That is, basic behavioral analytics is nothing but tracking the customer's information through Clickstream events and understand their intents and personalize their messaging for them or personalize their help. And then run the analytics, understand how many Stacy's and Lisas are there to understand much better and understand where we have problems inside the tax product. So we need to make sure that crunch all that data and do analytics on top of that. And moreover, to all that stuff, we need to provide the toolings with respect of our data discovery and understanding. I'll go on all the 3 sections as much as possible in high level. I'm sorry. So going to the behavioral analytics side, it's basically collecting the information when the customer is going through the tax filing journey. You need to track their events. If you are not organized, it's very difficult to understand. That's how it is started. When the TurboTax started, every functional unit and every section of it, they have their own mechanism to capture those kind of events, but that information is not standardized. Our goal primarily is we wanted to standardize that so that we can help our customers better. And the second part of the problem is we wanted to improve our analytics platform. I simplified the diagram here. The events being sent to Adobe Analytics, and early on it used to work properly for a cookie cutter analytics approaches. It worked very well. But when the business and the customers are growing drastically, our needs also increased. And then Adobe Analytics was not able to help us. We moved the data into a data lake from the feeds from the Adobe Analytics and tried to do our own analytics. But the scale and the volume is taking too much time for us to process and provide the information. And that analytics is not providing a real-time help to our customers. This is like a legacy architecture of how it used to look like. Don't worry, I'm not going through all the boxes. This is complicated. What I wanted to highlight here, it takes 4 hours to get any click information coming back to our infrastructure. That is what used to be there. Going to the other side, I was showing that library picture where it is not organized. With respect of the data, the way it used to looks like is this. This is how we used to capture the information. It's very difficult to tell which domain, where this event, what is that event for, and who is generated this event for. It's very difficult to capture that information through this mechanism. To modernize that aspects, we changed our mechanism, how we started tracking our events. We sent all the events directly to our Kafka clusters. From there, we sent it to Segment, which basically integrated with third-party tools. So we don't need to worry about that. In the second part, from the Kafka clusters, we basically added extra enhancements with respect of a geolocation, sessionization, and those aspects, and sent the data to a data lake immediately so that our data workers can be able to do the analytics on the data available in the lake. That's part of the infrastructure aspect, but we also standardized the way we wanted to capture the events with respect of a domain, which org purpose and scope, which scope area and the screens these events are generated, what in respect of a logical and behavioral aspect, the actions, objects, and the UI actions, what actions are taken, is the content viewed, or that kind of information is being captured, and who. IVID and a pseudonym ID is the 2 standards ways we are capturing. IVID is basically pre-authenticated way of identifying a customer, and a pseudonym ID is post-authentication. That is basically a textbook. Now how it looks like when we applied this into a theory. This, I don't know whether you guys see the lines, but it is clearly segregated between domain, where, and what, and who. So we don't need an expert to understand the events. It's across any of the platforms. Someone sees the event, they know that these 4 aspects very clearly. There are other aspects which I trimmed down because it's specific to the application purposes, but this is standard across the board, the way we used to capture the eventing. What this helped us basically understand the data better and also provide the personalized services for our customers with respect to intents, or understand their intent and provide the personalization through the machine learning. This data is fed directly to the machine learning models so that those models are recommending and the product is implemented. Going to the next part, which analytics at scale. This is more about the data it is generated. TurboTax at the peak season, we have 40, how do I explain? 40 billion tax records being created in 1 hour on April 14th, the tax day. So we need to make sure that our systems are scaled enough to process the data and generate the business insights and the customer insights at scale. The last item in this is real time. We have observed the real-time needs are very, very high, and it is going one use case to multiple use case exponentially. So we realized that we need to build a platform, how to build the real-time analytics at scale. Before I go into the details, I want to take a couple of steps backward to see how our analytics platform journey looks like. As usual, every company, the reporting started with functional groups, reporting silos. And basically the way I would explain is a reporting is done on top of their OLTPs or RDBMS databases. So the scope of that is, when we look into it, you can only generate the reports what that functional group is doing. You cannot generate the reports beyond that scope. That's a basic limitations. And then narrowing down the business needs. So understanding that, couple of leaders went back and said that, hey, we need to combine all these different data sets to get the better business insights. We bought a new MPP appliance and we hosted that into our Intuit data center, in-house data center. It's basically combining all different functional units data together and then run the reporting on top of that. It's basically analytics and AI on top of the MPP. It's an appliance. We immediately hit a wall with respect of a performance and a cost. So more and more data going in, then the cost is increasing and then performance is degrading. We realized it is not going to work. We need to think something else. That's the time we hosted a 200 node Hadoop cluster and moved all the data to the Hadoop cluster and asked our analyst and AI to use that. It was quite a bit success because theory of relativity, run a query, takes half an hour. Now it is taking 5 minutes. They're happy. But the tooling is very low. And the integration patterns with the Hadoop cluster to other PyCharms or Eclipses or to run the analytics on the different Jupyter notebooks is very difficult. Then we said, okay, we need to improvise much more than what we have today. We hosted a new MPP appliance in-house data center. Basically, the way that new MPP appliances, what we hosted, is basically not by the number of nodes. It's basically the volume of the data. So when we hosted, it was a huge success because the performance is better, moving the data. I remember moving like at 100 million records in less than 90 seconds, and querying the data and aggregating the data is very, very fast. But the challenges came along with that. Every analyst and a data scientist trying to move the data from data lake, Hadoop data lake, to MPP, and the data volume is exponentially increased because a lot of data is duplicated between things. Even the data is there in MPP, other analysts went there and then copied again because they don't know their data exists. And that increased our bill, licensing bill. At the similar time frame, we came across a situation, we need to migrate to a cloud because rest of the Intuit application systems are already migrated and it is our turn. So we got a task, migrate the data to a cloud and also reduce the bill. So we worked with AWS professional services and divided to convert that migration into 2 phases. First migration is focused pretty much on moving all the data from in-house data center to a cloud and make it up and running. So the way it looks like, I'm not going through all the animations. Let me finish it up. So the way it is towards the left, they have a different types of applications, which basically the RDBMS, OLTPs data, behavioral data through a Clickstream or domain events, and the third-party data sources. That data goes to our data lake, which is nothing but a Hive metastore and an S3 buckets with the Parquet data in there. That data goes from these systems through via Golden Gate replications or the stream-based approaches to data lake. We have our own custom built tools for that. And then we hosted that MPP cluster in AWS with EC2s and EBS volumes. And then we started moving the data through using the EMR clusters. That's the first time we started exploring our EMR clusters, how it works. And then a lot of processing, this aggregation, generating insights, everything is used to happen within the MPP. Our data workers started using the MPP for exploration purposes by directly querying through JDBC or some other tools what they used to use. And then they are also started connecting to our EMR clusters to exploring the data in the data lake. The footprint looks like 50,000 tables, 2.5 petabytes of data, and then there are 10,000 ETLs are there after we migrated to AWS cloud. This is not end of our journey. We started our journey, in my opinion, we started our journey at that moment. Once we finished migrating the cloud, 100% on the cloud, we started modernizing our infrastructure. The left side remains the same, but I forgot to mention in the previous slide, the main problem with there is the processing happening in the MPP. At the same time, data workers also executing the queries thing, and there is a resource contention was happening. So what we did was, hey, when the ETLs are running, we are going to remove the resource pools, reduce the resource pool for our data workers, and then let them give all the resources to the ETLs. And once that is finished, we will give the resource pools to our data workers. It's basically kind of a gating mechanism. That really didn't work because someone wants to get up and at 5 a.m. wants to see the data. And how does it work? Because the ETLs are still processing. Our SLA at that time is 9:30. Said, okay, this is not going to work. We wanted to make it better for our data workers. That is one of the aspects before modernizing our infrastructure into it. Coming back here, learn the lessons. The first principle we applied is we want to separate the processing and storage so that these two are completely disconnected. So we don't need to worry about resource pools. So the way we did the processing is using the three main things: EMR clusters, Redshift ETL clusters, and then AWS Glue. EMR clusters, basic Spark processing. It takes the data, processes it, and puts back the data into a data lake S3 buckets. But we are not able to use that for all the ETLs. There are some crazy ETLs which we are not able to process using a Spark because it was taking 2 hours, because we have to go back and crunch all the last 6 months of data and do all that stuff. That's where we started using the Redshift ETL cluster. It's much, much faster. The jobs are finished less than 15 minutes in Redshift ETL. And AWS Glue, it's basically simplified approach for connecting to any third parties through the AWS Glue connectors. That's how we get the data, use the AWS Glue to process the data and put back into a data lake. Once the generated data is inside, we move that to reporting cluster, Redshift reporting cluster. That's what is used by our data workers and dashboards being consumed, that data. And our data workers used Athena or Databricks SQL to explore the data in the data lake if they need to connect to a raw data. The Redshift reporting is also able to connect to the data lake data to the Spectrum. But remember, the Spectrum is always costly. If they run the huge queries, we end up paying more and more. So we recommended most of them, if you wanted to query the data, raw data in the data lake, go through Athena or Databricks SQL standpoint. The footprint after the upgrading this infrastructure is reduced drastically. Remember, the 2.5 petabytes of data came down in the Redshift cluster as 400 terabytes. And then ETLs reduced from 10,000 to 3,500 because we don't have to copy the data, duplicate the data from data lake to the Redshift. We made a principle that we don't want to move the raw data from data lake to Redshift. You wanted to use the Databricks SQL or the Athena or Redshift Spectrum. Data lives in the data lake itself. That helped us a lot. Going to the next one, which is I didn't touch upon about, is the real-time analytics. So this is whatever I explained. Many of the processes is more about a batch-based, but we also have a growing business needs for the streaming. We built a platform, stream-based platform. We call it as SPP, which is built basically based on simple principles. We want our engineers to focus primarily on the business logic, reading the data from the Kafka, do the processing, whatever the business needs is, and publish it back to an S3 or Kafka or other databases. But there is other part is pipeline. Pipeline takes the code, infrastructure, and deployment aspects. So you can run the same thing in multiple ways where your processor can be sequential or parallel, depending on the business use cases. This is kind of a high-level conceptual view of how we envision the stream-based platform. We built the platform based on the tech stack, which is engineers are only focused on the top part, which is Apache Beam. They write the code in Apache Beam, check in the code in the GitHub, pipelines built on our dev portal. So it is seamlessly integrated. Monitor your pipeline through the Splunk or Wavefront or any of these dashboards we already pre-built. Underneath that, we took all the heavy loading of running that code, what the developers produced, using the Flinks, RocksDB for maintain the state management, and then Amazon S3 for some of the state files, backup purposes. All this run in Amazon Kubernetes cluster. We have our own, it's not EKS, but it's similar to EKS. We built it inside the Intuit. We call it as IKS, but all that stuff is run under Kubernetes cluster. Can I come back to the questions later towards the end? Thank you. Key areas to focus next part is data discovery and understanding. So now we have tons of data. How do we make sure the data workers understand this data properly? It's a common industry problem. If you don't organize your data properly within your data lake, if someone wants to read a specific insight, generate a specific insights, he or she needs to understand where the data is, where the table is generated from, and can I trust the data? All those tons of questions comes in before I actually execute the data itself. I keep talking about data workers. I didn't specify who the data workers at Intuit. They're basically the business analysts. We wanted to crunch the data, understand and generate the insights. At the same time, data scientists, we wanted to understand the data and generate the models based on the business needs. And data engineers, basically, they crunch the numbers and generate the insights, provide those numbers for the data business analyst and data scientist. And BU developers takes these insights from all these three groups and say that, how do I integrate that with back to the product so that I can give you a better service for our customers? And data stewards, they are the domain experts in the respective business area. These we wanted to solve for them. If we solve for them seamlessly, they can solve for our customers. That's basically a two-level approach. The data discovery, this need to be happen in two phases. One is a data discovery, and the second part is an exploration. Discovery, I was explaining, where can I find this data? What is the data means? And then can I trust the data? If the data is refreshed, when it is refreshed? And then how this data is connected to other data sets which I wanted to explore. This tax return is connected to which billing item? That kind of an information they need to know. At the same time, how can I get an access to the data? This is a tax data. We need to make sure that principle of least privileged access. So they need to know who is the right person to provide an access, which data sources they can use to get the access, and which tools they need to use. How do they connect to that respective tools? And then they used to run a query yesterday, and why the query is slow, what's problem, what type of partitions they need to use to make sure that queries are running much faster. You need to know that how to connect it, how to use the effective way to use the partitions in the data lake so their queries runs much faster. This is basic problems. Partitioning is a big problem at Intuit because lack of understanding what are those partitions. The goal there is we want to organize the data first. Without organizing, creating their levels, like as we call it as L0, L1, L2, L3 level kind of a data. Without organizing that data, we cannot help our data workers to explore the data. Our approach is very simple, three simple approaches. We created a data map, which basically organizing the data, make sure that providing those links to our our customers, this data is linked to so and so areas of other data sets. And then we made a decision to build a tool for a discovery purposes on top of a data map registry, which is powered by MDR. MDR is metadata registry for us, which is behind the scenes Apache Atlas. And then we buy a tool, which is Databricks SQL, to integrate that seamlessly with the data map and data discovery parts. That's our approach. This is the tool. I cannot demo because of the internet connection and VPN purposes, but if you see, you can simply type in the table and you get all the table descriptions, and you see that where the table is. And if someone wants to understand more documentation about that table is provided the links. And also over the period of the time, how that data looks like and who the data stewards are. I blacked out, but that basically the data steward names, they can reach out if they need it, and they can request an access through them directly. Say that give me an access to this data. And also it gives you kind of a profile information, which I need to scroll it down. I cannot show you guys here, but trust me, there is profile information there. It is pre-captured. If they click on data, explore data through that particular link on top here, okay, this area, then it goes to the data exploration tool where they can execute the data after they get the access. We are not done yet. Our journey is still continue to progress. We are trying to still adopt some of the lake formation features, integrate with the Databricks and other tools what we have. So that's integrations are still happening. There is a lot of design going around and the work is happening. Slowly we are migrating the existing infrastructure, Hive Metastore to Glue Metastore. And also we are creating a data mesh architecture inside the Intuit so that we create a data as a product. The product has input ports and output ports and who the stewards and the entire metadata is captured as a part of that data product's deployment so that it is not scattered in multiple places. That journey, all we are going through, by end of the day, it comes back to the Lisas, Stacy's, and Leon. We wanted to help them provide the confidence in filing their taxes just in time. I'm done. I'm open for questions. You have a question, sir?
Yeah, so do you have is all your data in the cloud or do you have any?
We have all the data in the cloud. We don't have any on-prem data. We already migrated, that is our phase one of our migration. We don't have on-prem footprint at all. Very good information. We have a data classification built on. So we have classified our data into sensitive, highly sensitive, and all that information. When any new data comes to our lake or in the infrastructure AWS cloud, the domain owners need to classify the data, what type of data it falls under. And that is basically based on the data classification. We have a data classification storage mechanism. How do you persist the data into the disk? So for PI, sensitive or highly sensitive, we have our homegrown tool called IDPS, which basically secures the data. We encrypts the data or hashes the data and puts back into the disk. In case of sensitive data, we use the transparent data encryption, where the S3 buckets being encrypted with our own keys. And the access is given through the IDPS keys, which basically the key which you can use to decrypt the data. The key is given an access to only to the users who are eligible to decrypt it.
And final question, what sort of data science work is like the most important? What sort of
Think about this way. If I talk about a Clickstream data, and you said you are a family, that you have so-and-so changes in your life, and now you are going through the tax filing process. In between, you hit a form and you don't know what exactly you need to do there. And you are trying to understand what it is. In between, what happens is data science collects all this information runs the models and make sure understands which category, which classification you fall under, and provide an articles which directly helps you. That is the recommendation system. It's basically, it understands what is your unique tax situation and runs the models based on the data which is collected to serve back to the same customers. We have a policy called 7216, which is a regulation. We cannot use the tax data without the consensus to other areas. So we make sure that those are being followed while we are running our machine learning models. What purposes we are using the data and what data we are using. It is being carefully reviewed by our legal and compliance team. Yes, sir.
That data discovery app, did you build that, or is that off-the-shelf?
The question is, data discovery app is we built it. It is off-the-shelf product. We built it. We used to have a product. I don't want to name the product while it is recording, but it didn't really help our Intuit customers. There are so many limitations with that. So we end up building the tool, and we explored many of the open source tools or the industry tools. It was not helping because we wanted to make sure the connectivity is being established properly.
Take one last question, please.
Yes, ma'am. Yes, the real time needs basically helping the customers just in time what their needs are. At the same time, we are virtual experts, right? Our experts are helping our customers, and there might be a situation the time our experts is taking more. We need to know that this is something wrong in this particular area, and the expert managers can able to immediately intervene and provide the right level of help. So I'm just giving an example. We call it as customer service time. And then how that performance looks like. If we all of a sudden we get the call volume increases in a particular segment, we will need to make sure that adjust immediately for our businesses so that we can get more number of experts or other ways to tackle those kind of situations.
Thanks for your time.
So I'm available outside. I can answer offline. Thank you, guys.
Thanks everyone for joining, and thanks to you for the great presentation. Thank you, guys.
Yeah, sign out of that.